Hi, everybody. Mr. Dahl here. I wanted to make a clarification video for a couple things that you might have missed. If you've been learning at home the last couple days, I realize that maybe you need some further instructions on this document. If you haven't already printed this out and done it, or if you weren't here to do it in class, I have it posted up on Google Classroom and I have instructions with it. But it turns out the instructions were not clear enough. I apologize for that. So if you need some clarification, just watch the first part of this video. After I clarify doing this assignment, then I'm just going to go through some of our video lecture that we did for rocks and minerals in class. Again, if you haven't been here either Monday or Tuesday of this week, you might have missed some of this stuff. You should have at least been able to write the stuff down, but you weren't here when we talked about it, so I'll just add a little bit of detail to some of these notes here. First of all, let's look at this assignment here, because I know some people struggled with this at home. So this down here is just a diagram of the Earth with the layers from the inner core to the outer core, the mantle, the crust, and then above that I have the oceans and the atmosphere. And this is simply going along with the video lecture I put up earlier about the interior of the Earth. We mentioned how we know what the interior of the Earth is based on seismic waves. As earthquake waves travel through the Earth, we're able to use data as they come out on the other side. It's a little complex, but we basically use data of what's inside based on earthquake waves. And we have found that it gets hotter as you go deeper into the Earth, and also that the density increases as you go in. The heavy stuff is in the middle, things like iron, and lighter elements like the rocks at the surface are found here on the crust. And then above the crust is even lighter stuff, water in the oceans and the atmosphere that's above us. And so this assignment is simply applying some of the stuff that we learned a long time ago about density to the layers of the Earth. It's just combining a couple things and merging them together. So in order to do this, you would need to have a calculator in order to calculate density. Remember that density is equal to the mass divided by the volume. That's how you find density. Mass divided by volume. We learned that a long time ago, and we're going to use that today. So here's mass for substance A and volume. Here's mass and volume for substance B, etc. You simply need to take those numbers and divide them. For example, our first one is 152.6 grams for the mass divided by 33.17 cubic centimeters. I'll do this first one with you. 152.6 divided by 33.17. I just took the mass divided by the volume. I plug that into my calculator, and as you can see, I got this number. Well, let's just take it to the nearest tenths position. That means just one number after the decimal, so we're just going to round that to 4.6. So I would write down under density 4.6, and then for units, remember that you just keep whatever you have here, grams/cubic centimeters. So here I would have grams per cubic centimeter. Just be careful, because a couple of these have milliliters instead of grams per cubic centimeter. It'd be grams per milliliter. All right, so just bring the units over. Now let me just make up some pretend numbers so you can see how this is going to work. Let's just say that I do the calculations and substance B comes out to 10 grams per cubic centimeter, and these are not real. I'm just using this as an example. Substance C comes out at 2 grams per cubic centimeter. D is 20 grams per cubic centimeter. E is 15 grams per cubic centimeter. And F is 5 grams per cubic centimeter. So I just have some fake numbers here after let's just say that you do your calculations that come out like this. Yours won't, except for that first one. Oh, except for that this one, C and E shouldn't be per cubic centimeter. My mistake. What should they be? They should be grams per milliliter. I was going a little too fast there. Make sure the units line up. All right, now that I have my densities calculated, you're going to jump down here. You'll come back to the layers later. And you're going to look at these layers. I have these boxes where you can write the substance letter, A, B, C, D, in the correct spot. So how would you know which letter goes in the middle there? Well, as we said, the heavy stuff, the dense stuff, sinks to the middle. The inner core has the densest material. So all you need to do is look at your densities you calculated and say, okay, which of those is my biggest number? In my case, which these are not real numbers, but with my numbers here, it looks like D is the biggest density with 20 grams per cubic centimeter. So that means in the middle, I would write D. All right? Then I say, okay, what's my second most dense? For me, that would end up being E. So I'd put E in the next layer. It's the second most dense. And I'm just going to work my way out from the most dense in the middle to the least dense on the outside. So for me, that's D, E, B, F, A, and C. So you can see that if I look at my numbers from least dense to most dense, I put them with the most dense in the middle up to the least dense on the outside. Now, the last thing I'm going to do is come back and say, okay, that means that what are these layers? I know that the middle is the inner core, outer core, mantle, crust, oceans, and atmosphere. So now I just need to reverse it and say, okay, that means that D must be the inner core. Again, this is not what you should write there necessarily. I'm just using this as an example. Your numbers will be different. But this is the process you'll go through. So if that was my numbers, then okay, that means that D is the inner core, E is the outer core, and then B is the mantle. F is the next layer here, so I'm just working my way out. So B was the mantle, F would be the crust, A would be the oceans, and C would be the atmosphere. So crust, oceans, atmosphere. And that's how you'll do it. And then what you should do when you're done with that is bring it back to school when you return and turn it in, and I will grade it when I have it. So that's all there is to it. Find the densities and then put them in order, A, B, C, D, from the most dense to the least dense. Again, yours will be different than mine. And then use that to reverse and say, okay, that means that the one in the middle must be the inner core. The one here would be the outer core, the mantle, crust, oceans, atmosphere. That's that. Let's go through some notes really quick if you haven't been here for this. If you have and you just need to do that assignment, great. Stop the video here and work on that and turn it in. If you've missed these notes on rocks and minerals, if you weren't here either Monday or Tuesday, stay on the video for a minute. So we talked about rocks and minerals in class. Rocks are made up of more than one mineral. Just like atoms combine to make molecules, minerals will combine with other minerals to make a rock. So here we have a mineral on the left and some rocks on the right. A mineral by definition, and hopefully you've already written this in your notes because I posted these the other day. If not, pause the video and do it now. But a mineral has 4 properties. It must be natural, so it's not man-made. It has to be non-living, meaning it wasn't ever alive, not like a bone or like a dead tree or anything. It can't have cells in it. Non-living. It has to be solid, and it must have crystal structure. Now that 4th one, crystal structure, can be really tricky because sometimes, like in the picture on the left here, well, those crystals are very easy to see. But usually the crystals are very difficult to see and they're microscopic. So that one you really have to guess on sometimes. It's hard to know for sure. That's just how it is. It has to do with how the rock forms. It has to be given plenty of time for those crystals to form before it solidifies, which it often doesn't. But if you take a bunch of minerals together, you get a rock. Again, pause if you haven't written these down and write the definition here. A rock is made up of at least one mineral. So this mineral here is also a rock of one mineral. Or in many cases, it's made up of more than one mineral, like this piece of granite. Maybe you have granite countertops in your house, in your kitchen, or in your bathroom, the rock countertops. Maybe they're granite. Now, they might not look this color. You can see that this granite rock is made up of quartz, feldspar, hornblende, and biotite, and it tells you their colors. If you maybe have black granite countertops, it just means that there's more hornblende and biotite than there is quartz and feldspar. If you have a brown granite, you probably have more feldspar in it. And if you have a white granite like this, there's a lot of quartz in there. But this is an example of a rock, several minerals that are stuck together. By the way, a lot of people ask, well, why is that penny there, Mr. Dahl? You'll often see in pictures of rocks or rock formations that they put something else in the picture so that you know how big the rock is. It's just to show scale. So that penny shows you, oh, it's about that big. Whereas if you had a hammer in there, you'd say, oh, that's a bigger rock. Or if you had a person next to it, right there, oh, that's a really big rock. Put something in the picture for scale. After that, we just went through some pictures here. You don't need to write this slide, but as a class, we discussed whether some of these things are minerals or not. For example, I'm going to have you maybe pause the video here and say, is this a mineral? Yes or no, and why do you think that based on these criteria? It has to be living, non-living, solid, natural, and have crystal structure, although you can't always see that. So pause the video, think about this for maybe 10, 15 seconds. Do you think this is a mineral, yes or no? And why do you think that based on those criteria? Well, if you said this is not a mineral, you're correct. Because it doesn't meet all the criteria. It is solid, it is natural, but it does not have crystal structure, and it is a living thing. It's not non-living, so it doesn't count. How about this one? Same thing. Pause and think about it for a second. Is it a mineral, and why or why not? This is gold, by the way. This is a mineral. Yes, it is. It is solid, naturally occurring, non-living. And like I said, you can't always see the crystal structure. That one's always tricky. It's there at the atomic level, the microscopic level. You can't always see it. This cat, of course not. This thing is living, not non-living. Doesn't have crystal structure. It's not completely solid. It's got blood and guts in there too, right? This, sure. Solid, crystal structure, naturally occurring, and non-living. These Legos, these are definitely not natural, and they wouldn't have a crystal structure. They are solid. How about this one? I want you to think about this one for a minute. Ice. We're talking about ice specifically. Would ice be considered a mineral? Yes or no? Go through the criteria. Does it match them? Think about it for a second. What did you think? Well, let's go through the things. Is ice natural? Is it naturally occurring? Sure. Yeah. Now, you can make ice in a freezer, but generally, you can find ice in nature, right? Like snowflakes or glaciers and things like that. Okay. Does ice have crystal structure? Absolutely. Look at that snowflake there on the right. See that crystal structure in there? Again, sometimes you can't see it, but it's definitely there. Is it non-living? Absolutely. Don't be confused. Remember, living things need water, but water itself is not alive. And is it solid? Well, this is where sometimes students get a little confused. They say, well, yeah, but it can melt into water, right, at low temperatures, so it's not always a solid. Well, that's true, but we're talking about ice in particular. Is ice solid? Yeah, sure it is. Yeah, you can melt it at the right temperature, but can't you also melt this at the right temperature? Sure you can. It's got to be hot, but you can melt that into a liquid. Can you melt this? Sure, at the right temperature. Can you melt oh, that's horrible. Why would I say that? I'm sorry. But yeah, you can melt these things. You can melt ice. Now, as long as it's solid, yeah, it technically counts as a mineral. It meets those 4 criteria. What about now? Is it a mineral now? No. As soon as you melt it to a liquid, it no longer is technically classified as a mineral until it resolidifies again in nature. So does that mean that this, if you melt diamond down, would it be a mineral anymore? No, not while it's in that liquid phase, not technically. These are all classifications that people have come up with, right? So is that a mineral? Yeah, now there are some scientists who would disagree. There are some who would say, well, when you're talking about it in a geologic sense, it doesn't form like rocks do, et cetera. So there are some who would argue that and say, well, yeah, it meets the criteria, but it's kind of an outlier. We're going to ignore that one. But many scientists say, yeah, it's a mineral. It meets the criteria, so we include it as a mineral. Depends on sort of who you're talking to. We'll consider it a mineral for our purposes. And of course, no. All right, the last thing you need to do, we did not talk about these in class. We'll talk about them on Wednesday. But if you haven't written these down, make this list in your notes as well as this list in your notes, and we'll talk more about it tomorrow, okay? You can pause the video on those slides or just go to the slides that I posted the other day, and you can write down this and all of this as well. Tomorrow, so this is Wednesday and Thursday, we're doing a big lab in class. This is a 2-day lab, okay? I don't currently have a way of you doing it online. I'm thinking about if there's a way I could get you to actually be able to do it online. I'm not sure yet. Right now, I'm just thinking that you'll just need to do it when you get back to school. So if that's the case, you'll need to come in before school or after school. It's going to take you a little while to get it done, but it'll have to be made up at school. Okay? All right. Hopefully I see you guys soon, and we'll talk to you later.